Welcome. So I'm Adam Mooney. I direct the Mariner S. Eccles Institute here at the business school. And I'm here to welcome you and to introduce our guest today, Conor Walsh. He is an assistant professor at Columbia Business School. He's an expert on energy markets, on economic growth, on firm dynamics. And he's here to speak with us today about how falling prices for clean energy investments like solar panel prices and prices of wind turbines are going to impact economic growth and living standards in the US and also here in Utah. For those who have been at one of our lectures, you know the drill, but for those who have not, the way this is going to work is that I'm going to turn this over to Professor Walsh. He's going to spend about 30 minutes going through some slides, no equations, but some slides about describing his research and its implications for the US and for Utah. And then I will join him up here. I'll ask him some questions, and I will then open it up to questions from you in the audience. Cool. Okay, so without further ado, I'm going to turn it over to you. Thank you very much.
No, thank you. Thanks so much for having me. Yeah, so I think everyone's kind of aware, but we are at a pretty exciting time for power markets in the US. So renewable energy, meaning new renewable energy, so solar and wind, has been increasing rapidly over the last 15 years. From basically nothing in 2010 to now we're getting around 15% of our energy now from solar and wind. And it's been different across different parts of the US. So the Midwest is doing really well with lots of wind. California and Texas, lots of solar power. Less quick in the Northeast where the resources aren't quite as good, but most of the country is transitioning rapidly to renewable energy. And when you look at the flows into new generation, you just see all the new investment in the US is just dominated by renewables. So that blue line up there is investment in new capacity coming from solar, wind, and batteries. And so that's just been on an upward tear for the last 10 years. The black line, coal and gas, those are our dominant fossil fuels. As a group, they've been exiting the grid. And really what's happening there is coal is rapidly shutting down in most places in the US. It's increasingly uneconomic. Gas was continuing to be built fairly rapidly up until the last 5 years. And in the last year or two, we've seen almost a freeze on gas investment in the US. And really nothing much else is happening outside these sources. When you look at hydro, you look at nuclear, you get some variations here and there, but just not much of a story going on. Now, this is not really being driven by policy. This is part of a worldwide shift going on in power markets. And it's coming from declining capital prices for solar and wind, basically making solar panels cheaper and cheaper and cheaper, and wind turbines bigger and bigger and bigger. So if you look across countries, these are kind of just major industrialized countries, Australia, China, India, the US, you see the same thing going on. If you look at the all installed project costs of solar and wind without subsidies, every year they just keep falling and falling and falling. Solar is very quick, minus 15% a year. That's about as fast as any industrial good falls in the data anywhere in the US. It's not quite Moore's law level, but it's pretty close. Wind is slower, so wind's sort of minus 4% a year, but it starts off of a lower base than solar. And now we're roughly at the point where they're equally cost competitive. But for me, I mean, the main story is what's been happening in solar. Solar is a juggernaut. This trend in panel prices getting cheaper and cheaper and cheaper goes well back to the 1980s and 1970s. This chart's sort of linear on a log scale, but you can see if you tried to put solar panels on the roof of your house in 1980, it would have been multiple millions of dollars. Now we're down to just a couple of $1,000 to get them up and running. And most industry experts predict this to continue well into the future. It's being driven by a combination of learning by doing, technological innovation, scaling up massive production in China that we're just seeing continued rapid cost declines. You can see that dot for 2023, we just saw a 50% decline in 1 year in panel prices. So this has got some room left to run. In fact, if you look at a world scale, this is the fastest transition for any power technology in history. So just look at years since passing a certain minimum level. You can look at gas, coal, hydro, how much is installed at the world level. Solar is going far quicker than anything. So wind and nuclear were pretty rapid build outs. Solar is going much, much quicker. And I think it's fair to say that, despite these trends going back into the 1980s, pretty much no one saw this coming in the last 10 years. So this is a chart I stole from the Economist. What's this? This is, the black line is how much new solar capacity is getting added to the world grid every year. So just an exponential explosion. And the yellow lines are the predictions from industry experts or the International Energy Agency. And basically what it looks like they were doing is every year they'd see solar installation go up and up and up, and they just update the line on the spreadsheet and say, okay, that's going to continue at a flat level from here. So, predicting exponential change is kind of hard, we know that. But certainly if the recent past is going to be anything like the near future, we can expect this to continue. Now, of course, renewables suffer from a drawback that is not apparent for fossil fuels like coal and gas. Coal and gas are always there. You can ramp them up and down at will. Solar, of course, not there at nighttime. But we've also seen another really encouraging trend going on with battery prices. They're following the same log linear decline, so exponential falls in prices from 1990s just being supremely uneconomic to now falling at sort of 20, 30% a year. A lot of that recent progress is being driven by the uptake of EVs, but we're also seeing huge amounts of storage being added to the US grid, the Chinese grid, the European grid as well. And again, most industry experts would say this has got a long way left to run as well. We're coming up with new battery chemistries all the time. We're economizing on the use of materials, and battery prices are just getting cheaper and cheaper. Yeah, and as a result, you start to see this on the grid. So this is the California grid. This was April last year. See that big chunk in the middle of the day? That's all the solar panels in California supplying the grid. And of course, they're not there at night. But notice what else you see, a big chunk in the evening peak when the solar panels turn off, those are batteries ramping up. Those batteries were not there 2 years ago. And now we're already getting 20, 30% of the evening peak coming from batteries. And if you look at, the pipeline for installation of these batteries, they're also exponential. So the model we're increasingly seeing across the US is cheap solar power in the middle of the day, driving power prices down, batteries soaking up that cheap power, and then providing it when it's needed, when everyone gets home from work, turns on the TV, starts cooking dinner and the like. Now, this is a pretty rosy picture, right? This seems like everything's going to be great in the future. There are big problems though. One of the biggest problems we're seeing in the US is a big congestion in what's known as the interconnection queue. So when you go and try and connect a solar plant or a gas plant or anything to the grid, you have to do sort of interconnection studies, environmental studies and the like. Historically, this wasn't a huge problem. It would take a power plant 1 to 2 years to get connected to the transmission grid. Now, the average wait across the US is sort of 5 years. If you want to set up a solar plant today and you've got the financing, you've got the modeling, you've done, it'll be 5 years before you can start supplying power. And as a result, you're just seeing congestion in this queue just go up and up and up. There's many terawatts of projects just waiting to get a connection agreement with the grid. In fact, if you just add up all that solar and wind and the batteries there, that's more than enough to completely replace all the fossil fuels in the US with renewables. Now, it's not like all of that's going to get built. In a 5-year interconnection period, some stuff, always happens. Your financing might fall through, or the project just runs into difficulties. So some of that is going to fall out of the queue. But if even a decent fraction of that gets built in the next couple of years, we're looking at a very rapid transition to a renewable-dominated grid. Now, I think that the open question is, what does this do to power prices? What does this do to the cost of supplying electricity to industry, to residential customers, to commercial installations? Renewables are different in a couple of ways. I mentioned intermittency. But for power prices, the big thing that's different about renewables is they have essentially zero marginal cost of supply. As in, you set up a solar panel in the sunshine, you put a wind turbine in the wind, it just starts generating electricity and you have to do very little. Unlike fossil fuels, you have to burn something, and burning something costs money. What that means is once we start to transition to a renewable grid, you need to think more and more about the upfront capital costs of building this stuff. Now, what are the components of the capital costs? Well, there's a couple of big buckets right now. Well, this was 2024. If you want to supply completely firmed solar power, as in enough battery backup to make it dispatchable at will, so sort of 8 to 10 hours of lithium-ion battery backup, you need about $2,000 per kilowatt, and the battery cost is half of that. The rest of the cost, well, the panel is actually a smaller and smaller component of this cost, just because the falls in the panel prices have been so dramatic. What else? Well, that BOS, that's called balance of system. That's things like inverters, racking, mounting, these sorts of things. Those have also been falling in price about as fast as the solar panels themselves. So big components of the cost, that blue, light blue, and yellow, scaling up production and pushing down costs is driving these capital costs down. There are bits that you can't really do that much about. Field work is the labor required for setting these sorts of things up. Regulatory costs of applying. Land costs are going to be there, and they'll be very different in different parts of the US. Probably not going to change much into the future. But if you project forward, say to 2040, on what people think these things are going to cost into the future, you're looking at basically a fourfold reduction in capital costs from this point out to the future. Now, what does that mean for prices? Well, you can, we've done in our work some simulations of what power is going to cost if these capital prices are realized by 2040. And this is just a map of the US. These are all little counties in the US. You can see dark blue, the best solar resources in the country, so Arizona, but also Utah, importantly. Power is probably going to cost something like $15 to $20 a megawatt hour. Now, how does that compare today? Power can go for anywhere from $50 a megawatt hour all the way up to $100 a megawatt hour in the Northeast. Where are you not going to see this so much? Well, that dark red bit, that's the Acela corridor. So that's Washington, New York, Boston, and the like. Reason why you're not going to see it that much there, not because the solar resources are bad, it's much worse than Utah for sure, but land is just super expensive there. So you're not going to see solar farms built in downtown Manhattan, for example. But where you are seeing it built is exactly these dark blue areas here, on federal lands, on private lands, all across the West. Now, yeah, this is going to be a significant drop in power prices, particularly for the West. So power has historically been expensive in California and the mountain states. You're looking at like an 80% decline in power prices out in the West, or at least that Utah and other Western states could have access to. Less dramatic in the rest of the country. Wind's already cheap in the Midwest. A lot of this isn't going to get built in the Northeast. So this is really, to me, it's a Western and Texas story. Something that often comes up with this is, do we have the land, right? Solar and wind are very, very land intensive, wind particularly, but solar very much so. You need more land than a coal-fired power station to set up an equivalent amount of solar energy. I think in the aggregate, this is clearly not a constraint. If you just look at the US and you look at how much developable potential land there is that you could put solar panels on or wind farms, you could power all of the US today with 0.6% of the land. Now, 0.6% is not nothing, but for reference, that's like 5 times the amount of land that you would use for golf courses in the US. If you look within counties, each one of these dots is a county. Most of the counties in the US, you can supply them almost entirely with renewable energy within 100 miles of that county. Even places like Manhattan, like Boston, that are super, super dense, there's enough private and federal developable land within 100 miles of these places that you can get a long way to fully supplying them with cheap renewable energy, just locally. Now, because potential, and I should say as well, this is all happening on the utility side. In the US, we haven't seen that much development of rooftop solar yet, unlike a lot of other countries. So Australia, where I'm from, is maybe 5 to 10 years ahead of the US down this journey. And in Australia, 1/3 of the roofs have solar panels on them by now. US, it's much lower. So Google has this really nice data mapping out the roofs of the US using satellite data. And you can look at how much potential space there is for solar panels on roofs in the US. You can get most of county demand just from rooftop solar. You don't even need utility scale solar. So as soon as this starts scaling up more, we're gonna see big price pressures, not just on wholesale costs, but on the final distribution cost to residential consumers. Now, that's good in many ways, right? So cheaper residential power bills, everyone likes that. It's also going to be important on the production side. So this is going to be very good for labor, for wages, and economic growth, particularly in the West. Now, how do we know who's exposed to this sort of stuff? Well, industries with higher electricity shares are going to be very exposed. So AI, data centers, aluminum smelters use vast amounts of electricity. Most industries don't use a lot of electricity, service industries and the like. So New York in particular, not very exposed to this sort of change. Salt Lake City though, if you do some simulations, you get about a 5% wage change, wage growth, just from transitioning over to renewable energy. So that's quite substantial. And I think that the open question right now is, how do we get the amazing solar resources in the west of the country transmitted all the way to the load centers, which are really in the east of the country, and California is another big load center. So this is some data we collected on the transmission grid of the US. And you can see it's kind of pretty sparse in the west. So thickness and redness of the lines is how much transmission capacity there is county to county. There's just not a lot of, you can think of like highways, there's not a lot of highway space to be able to take power from the west into the load centers of the east. But if you could build that, we've done some modeling about this, if you could build that and connect the west to the east with lots of transmission capacity, you basically double the economic prize on offer. You double the wage gains, double the GDP growth. So what would that look like? Well, you would look at, if you were able to get the whole country connected to Utah's cost of solar by 2040, you're looking at $300 billion extra GDP a year. That almost justifies any investment you can think of. So it really is quite a significant prize on offer. Now, for Utah specifically, there are some issues that we have to think about. When you look across the country, the transition's really happening fastest in decentralized markets. So historically, electricity generation was done in vertically integrated structures. So you'd have one monopoly running the generation, running the high voltage transmission lines, and running the distribution. In the 80s and 90s, there was a wave of decentralization across parts of the country, so Texas and California in particular, separating the generation and the distribution. What does that mean? Well, private companies can now build and bid into power markets in Texas and California, build their own solar, wind, gas stations, and compete for generation. Not so in Utah. Utah is one of these vertically integrated markets where Rocky Mountain Power essentially supplies 80% of the power for the state, but also runs the poles and wires. And in these sort of vertically integrated markets, it's just slower. Why is it slower? Well, you've probably heard in your classes about the arrow replacement effect. What's that? Whenever a new technology comes along, who's the quickest to take it up? It's always new entrants. Incumbents have legacy businesses to protect. Rocky Mountain Power has about 50% coal capacity and 30% gas. So their legacy assets, they want to protect some of those profits, and they're not as incentivized to invest in solar and wind, just because they've got these existing assets that were built in the 70s and 80s. They're fully depreciated, fully paid off, and you don't necessarily want to close those down for new solar and wind. And that's why we're seeing kind of headlines like this. So this was last year. So Rocky Mountain Power in the new resource plan said, well, actually, we're going to keep burning coal out to 2042, which is well beyond the projections that most energy economists would say. And in fact, just a week ago, they updated that to say, we're going to do it indefinitely. We don't see a role we see a role for coal well into the future. I've got to say, I've seen stuff like this before. So in Australia, I've seen headlines many times like this, that utilities will say, no, we're just going to keep burning coal and gas and not really transition to renewables. And then very suddenly, they make the switch and shut down the plants. Why? Well, even for Rocky Mountain Power, they own coal-fired power stations and gas stations that are depreciated. If you want to think about just the raw cost of burning a ton of coal, something like $20 a megawatt hour just for the coal. And of course, there's also depreciation costs, maintenance costs, paying your workers and the like. In the next 10 years, new build all-in firm solar with batteries will cost less than $20 a megawatt hour. So even if you're Rocky Mountain Power and you've got these legacy assets, if you don't transition over to renewables at that point, you're ignoring your fiduciary duty to your shareholders. You're not maximizing profits. So I think we're going to see an about face on this at some point. Now, I think an open question, especially for you guys, is power is going to get cheap. What do we do with all this cheap power? So I left the slide blank because I think we really don't know. I think there are a lot of startups trying to think about this quite seriously. But if you think about electricity that's too cheap to meter, what would you do with it? I've seen proposals for desalinating huge amounts of water and pumping it up into the West and irrigating it. This starts to become feasible when energy is almost free. You can think about vertical farming. You can think about AI data centers. You can think about hydrogen fuels. All kinds of things become possible. But if you know this is coming, at the back of your mind, you can start thinking what to do with it. And then I just want to finish by saying, we may be about to enter a new era of growth. So there's been a lot of excitement and hype about AI and the technological possibilities of AI. And I think this is very real. But at the same time, with the power system shifting over to cheaper renewable power, it's like a force multiplier for that trend. AI data centers, very, very power hungry. Now, we've lived in an era of expensive fossil fuels for the last 50 years. If you know something about the history of energy, from sort of the 1900s right up to the Arab oil embargo, fossil fuels were cheap, plentiful, the price was stable. Then 1973 Arab oil embargo happens, the price shoots up and becomes high and volatile ever since. So we've been subject to these large swings in energy markets worldwide, and that has led to all kinds of defensive investments and slow productivity growth. You can kind of just see it on a chart, in fact. If you plot GDP per worker, just log linear trend, there's a very fast period of growth right up until that Arab oil embargo, and then the trend flattens again. And economists have done a lot of work on this and think at least a good part of that flattening of the trend in economic growth and prosperity is due to expensive energy. So what happens if we remove that resource burden and go back to the growth rates we saw in the 50s and 60s? Fast economic growth comes back. So I think this is pretty exciting. I've been working on this for a while and I see no signs that this is slowing down. So I'll take some questions, I guess.
Thanks so much. Okay, so I'm going to ask some questions, and then I hope you will join me in also asking some questions. I just want to start with some basic facts and just make sure I'm understanding what's going on here. So the first thing is that all of this seems to be arising because of declining capital prices. And I think one of the questions is why are these renewables so different from fossil fuels?
Yeah.
And why aren't we having similar technological change? And why aren't things like the fracking revolution, persisting and continuing to be competitive in your forecasts?
So I think there's some fundamental differences when you think about capital costs for renewables and building large, complex coal-fired power stations and natural gas. Renewables are what we call modular technologies. So they're basically stacking together rows and rows and rows of the same thing. You manufacture a solar panel, you manufacture a wind turbine. There's very little variation in the design, and you can build these things in any size you like. So that gives rise to economies of scale. Right? You build larger and larger factories, the average unit cost of this stuff goes down. When you build a coal-fired power station or a natural gas plant, these things tend to be bespoke. They're very complicated, they take years to design, all kinds of possibilities for cost overruns. This is not something that lends itself to natural, fast technological development. And the other thing to say is we've had coal and natural gas for 100 years now. These are relatively mature technologies, and the space for continuing innovation in these things probably limited. I won't say definitely, but probably quite limited.
And then in your price projections, how much is being driven by things like the investment tax credit, the production tax credit, these renewable energy subsidies that are recently extended by the Biden administration, kind of under threat from the Trump administration, and how much of this is the federal government putting their thumb on the scale?
Yeah, almost nothing. So the projections I showed you just there have nothing to do with investment tax credits or production tax credits. So for those who don't know, in 2022, President Biden passed the Inflation Reduction Act. One big part of this was a $100 billion production tax credit for renewable energy, $28 a megawatt hour. Very, very generous. And so we did some other modeling, some other papers on how much this speeds up the transition, and we thought it sped it up quite a bit. Now it looks like the new administration is probably going to aim to take this away. But the trends here are not being driven by policy. This is happening all over the world. Massive scale-ups in manufacturing in China, the US, India. These are things that the Inflation Reduction Act going away is not going to stop. So I'm pretty confident about where this is going.
Okay, and then on the benefits, you have these projections of rising wages in areas where prices are falling, and I just wanted to expand on that. So what is going on in terms of who benefits? Why do they benefit? Can you walk us through?
It's really a combination of two things. Solar is getting cheaper much faster, so the dominant thing in the end is where's all the sunlight, and the sunlight in the US, as we know, is in the West. And you want to multiply that essentially by the industry shares of electricity in different places. So different places have different electricity mixes. If you do a lot of manufacturing locally, you have a big expenditure on electricity. If you have a lot of services, finance, management consulting and the like, electricity is not a super huge concern. And in a whole range of economic models, that electricity share is basically a sufficient statistic, we call it, for what's going to happen to labor if prices fall. All you need to know is how much you spend on electricity to project increases in labor demand. So, where's all the manufacturing multiplied by where's all the sunlight in the US? These are the places that are exposed.
And then another thing I find striking about your talk is that it's ostensibly a talk about clean energy and renewable resources, but you haven't mentioned anything about climate. You haven't mentioned anything about local environmental benefits from switching from, say, coal that produces local particulate emissions to clean energy.
Yeah.
And I guess I'm wondering, is that a deliberate choice? And then how can we think about the other benefits?
No, I hear you. I almost pull a bait and switch when I do a talk like this because I call it the benefits of clean energy, but there's nothing about CO2 here. This is purely about price trends. So if you add in the environmental benefits of shifting to renewables, obviously that's much better. But my point is we don't even need to think about that anymore. These trends in the power sector are not going away, they're getting stronger. And whether you think about pricing carbon or not, this is going to continue.
Okay, some other clarifying questions. The West benefits a lot, and I guess why is this not like pouring water into a pool? Like, why doesn't the whole country benefit when capacity increases here?
Yeah, I mean, that's kind of an apt analogy, actually. If you think about power systems or transmission of power as like a network of pipes, if you pour water into a part of the network of pipes, how much is going to come out, say in the east, at the end of the pipes, depends on the capacity of the pipes. That'll regulate where the flow of the water goes. And there's just not a huge amount of transmission capacity. Those big towers you see out by the highway, connecting Utah, connecting California and Arizona to the east of the country. The Biden administration did a lot of thinking about how to continue this build out. And I think it was almost a bipartisan consensus that we need to accelerate this transmission capacity. But there hasn't been a lot of money put directly into transmission. A lot put into generation and also things like EV subsidies. But it's kind of a fundamentally hard thing to do because there are overlapping jurisdictions, federal, state, cross-state boundary regulatory organizations that all kind of have to work together to get one of these cross-state transmission lines up. So, I mean, this is a problem. It does constrain us if we don't build this stuff. It doesn't derail the transmission though. So even if you don't build the transmission towers, you still get a lot of investment in the Northeast. It's just not nearly as cost effective as it would be if we did it here in Utah and then pipe the power to the rest of the country. So there's an opportunity there, but I think it's not so much on the private business side, it's more on the regulatory side and getting some of these different agencies to talk to each other a bit better.
There was almost a bill to expand transmission and I think reduce permitting that Manchin, I don't remember who the co-sponsor was. That obviously died, but I mean, do you think that there are prospects for that? And
I think I was more hopeful in the Biden administration that this could be a bipartisan issue because, this does benefit fossil fuels as well, building out more transmission. But I think it became increasingly obvious to maybe the Republicans in the Senate that, while it may benefit fossil fuels, it really benefits renewables the most. So if you're ideologically opposed to renewables for whatever reason, building out transmission is just going to help renewables. And so the bill kind of died. And that's unfortunate, but I don't think we're never going to see progress on it, whether it's in this administration or the next, just because, as I said, the prize is so big to build this out, not environmental benefits, just in economic growth. If we could get this off the ground like China does, we'd be looking at huge savings in power costs.
Okay, I wanted to ask you about some risks to your projections. So, that the obvious criticism of renewables is that when the sun goes down, the power goes off.
Absolutely.
And when it's not windy, like the turbines don't produce, and that has a couple problems. One is just that intermittency, and so one potential consequence is that you have to build up excess capacity, and so the actual cost is higher than you expect. You have to have kind of backup standby baseload power, and that's going to persist. So you're going to have to keep running coal or nuclear or at least have gas available. And then even another problem is that what do you do when the price of power might fluctuate during the course of the day? You have periods where it's zero or negative, and other times when it's very expensive.
Yeah, so we already do see that in large parts of the country. If you look at wholesale prices in California or Texas in the middle of the day, they frequently go zero or even negative. Meaning if you want to generate power and supply it to the grid, you actually have to pay to do that. And what that means is a huge opportunity for battery storage, right? For me, this intraday variability is practically solved by lithium-ion batteries. Now, of course, it relies on them continuing to get cheaper from here. If they just stop getting cheaper at this point, it's going to be much more difficult to transition to renewables. But, the EV industry is massively scaling up. The US is not the only country in the world trying to manufacture batteries. China is trying, Europe is trying. We're going to see these things continue to get cheaper. Now, but that's, of course, not the only kind of variability that matters for renewables. It's not just about the day-to-day fluctuations, night and day, or windy weeks and not so windy weeks. It's also a seasonal issue. So there's a lot less sunlight in the winter, as I'm sure you've noticed, than there is in summer. And what that means is if you want to supply winter demand fully with renewables, you basically have to overbuild the capacity. You have to build more than you would need in summer to supply winter. Now, I want to say, a lot of what I'm saying here doesn't rely on going to a 100% renewable grid. I think we're going to see natural gas backup for a very long time. But I'm not particularly worried about having to overbuild for winter and then having excess capacity for summer, because the market is just very, very good at thinking up uses for cheap power. So if we see oversupply in the summer and we see prices plummet to zero on really, really sunny days, there will be smart, talented entrepreneurs, such as yourselves, who'll come up with things to do with that. I think the seasonal variability is probably going to be solved by overbuilding and keeping around natural gas backup for a while. It won't be supplying the grid most days, but maybe in heat waves or winter storms, you'll see the gas capacity used. And it'll be very, very expensive to supply at that point. So there'll be incentives to keep innovating.
The other obvious risk is political.
Yeah.
And so, you've said that this is not a trend that is driven by subsidies or regulations, but I mean, how much can those accelerate this transition, and how much
they can certainly accelerate it. I mean, I'm less worried about canceling the tax credits. I think what we've seen in just the last week or two is the Trump administration playing with executive orders to restrict development on federal lands and more broadly. So we've seen executive orders essentially banning permits for offshore wind and onshore wind, just out of ideological opposition, let's say. Now, whether those stand up in court is going to be an interesting question for the year. I think solar, usually faces less community opposition than wind does, purely as a fact that it's just not quite as visible as wind turbines are. You can see wind turbines from many miles away because they're as big as, bigger than the Sydney Harbour Bridge at this point. And solar is just flat. You essentially can't see it once you go off the road. So you don't tend to get quite as much community opposition to solar. But it does seem like the new administration's listening to fossil fuel interests more than the renewable interests. And that could pose a challenge or a threat to being just able to develop this stuff in the first place. So, I don't see the price risk there from losing the credits and subsidies, but I do see a regulatory risk from the federal government of just trying to ban this stuff. There will be court challenges, but these things take years to play out, and it could be a freeze in the next couple of years. We have to kind of wait and see. I think the long-term technological trends, there's not really much the US, big as it is, can do to derail this at a global level, but we may slow down within the US. That's certainly true.
And then what about within Utah itself? You already mentioned that we kind of have a monopoly power provider. I think that we have large coal production areas. There's like a local political issue about saving those jobs and things like that.
Absolutely.
What are the barriers at state levels, and in Utah?
Yeah, that tends to be a problem in the regulatory process in that fossil fuels are not only they're expensive, they're quite labor intensive. So supplying jobs to power plants, you need quite a lot of people to staff a coal-fired power station. For a solar plant, you don't really need that many at all. You need someone to kind of check things are working, but that's about it. There's not much labor involved. And what we tend to see is places that transition to renewables very quickly, like California, see big layoffs in the fossil fuel industry. And that is a political issue. There's no question about that there will be pressures to try and protect these jobs. And then, does Utah's regulatory structure, this vertically integrated monopoly model essentially, slow down this transition, or can you convince the shareholders and the regulatory agencies that this is just a technological advancement that will make things cheaper? I think it's an open question, but it's certainly a political one.
Do you think that there are things that our local legislators could do or to accelerate this or to unlock these gains?
Yeah, so, Rocky Mountain Power is privately owned. It's essentially owned by Berkshire Hathaway, Warren Buffett. And I think it's hard to get past the arrow replacement effect that, the incentives are just not as strong if you've already got these depreciated assets. But the thing to remember is keeping your eye on these trends. They are getting cheaper every year. Means these things could change quite quickly. Switching over to renewables can be just a question of a year or two once the coal becomes uneconomic. We see this all across the country.
Do you have questions? I'll go with you first.
Hi, my name is Marley.
Hi.
I was wondering if the analysis of kind of the capital cost decrease for solar included some of the capital costs for transmission infrastructure that are also going to be required, and then even just renewing, a lot of our transmission lines are very old, and that infrastructure needs to be replaced, which is going to be very expensive. Do you see that as a significant enough cost to inhibit the consumer price decline that we're kind of expecting from this?
Not so much, just because, again, these are modular technologies. So the old model of utilities is that you build big power stations outside load centers and then do a couple of high voltage transmission lines to them. Solar and wind you can build in any size. You can build at 50 megawatts, you can build at 2 gigawatts, which kind of more naturally leads to distributed generation. You don't need such massive corridors for power transmission. You can locate it closer to the load centers if the land's available. So that's one thing. I think, we have seen less technological development when it comes to transmission lines. Essentially they're just big steel towers with copper wiring. A lot of it, you're right, does need to be replaced, and that will happen anyway, whether this is renewables, whether this is a fossil fuel grid. But no, those capital cost projections are purely about building the solar farm itself.
Right there.
Yeah, Utah has a pretty ambitious plan called Operation Gigawatt to double power production in the next 10 years. Sounds like you've heard about it. I mean, it seems pretty clear from what I see. Would you agree then that the renewables, just from pure economic sense, is the way to go to meet that goal?
Absolutely. I mean, I think the other thing to keep in mind with this is this stuff moves so fast that people's knowledge is out of date if you don't keep track of this every year. So with the cost declining for solar panels 50% in 2023, what you thought you knew 2 years ago is no longer relevant. And I think, the private sector is much better at keeping up with how fast things are moving than regulatory agencies. So there's something about, needing to inform regulatory agencies continually about the world is not like what it was 2 years ago, and 2 years from now it's not going to be the same.
Can you talk a little about nuclear? It's
Yeah.
being talked a fair bit.
So the US nuclear fleet supplies about 20% of US power, and it's been doing that since about 1980. These nuclear plants are quite old at this point, but the Department of Energy did a study and said there's no barrier to extending the useful life of the nuclear fleet essentially indefinitely. So we can keep these nuclear plants out, keep running and supplying 20% of the power into the future. What is difficult, really difficult, is building new nuclear. And it's not so much a technological challenge. If you just think about the raw costs of building nuclear power, fission power, it's pretty cheap. It's also like a almost zero marginal cost supply technology. But the problem is, ever since 3 Mile Island and Chernobyl, first of all, the public really hates nuclear. Whenever you do a survey of should we expand nuclear capacity, it's a resounding no all over the world. And two, there's just so much regulatory burden on building these things. You have to track every screw essentially from the mine to the installation in the facility and have a detailed supply chain log of this. That just adds tremendously to the cost. And even places like China, where this is less of a burden, they're seeing tenfold greater investment in renewables than they're seeing in nuclear. So I see nuclear continuing to supply a decent fraction of power well into the future. I don't see a lot of expansion in the fleet likely to come. Now, one interesting issue is, we've seen in the last year power purchase agreements signed for existing nuclear facilities that closed down, particularly with AI data centers, restarting 3 Mile Island, That's relatively easy to do from a technological and regulatory point of view. So I think we'll see that. We'll see our existing fleet utilized almost at 100% well into the future. But building anything new, the UK has had massive problems building new nuclear. You've probably heard of Hinkley Point B, one of the biggest power stations in the world. It's taken 15, 20 years to build. It's twice overrun on the budget. It's just really, really expensive and difficult to build this stuff. Now, you've probably also heard about Germany closing down its nuclear plants. I think that was a catastrophic mistake. Certainly, essentially shooting yourself in the foot, closing down carbon-free power for ideological opposition. I hope we don't see that in the US, and I don't think there are signs we will, but it's something to be mindful of.
I've heard the story a couple times where it sounds like the regulatory burden, whether it's on building a plant, whether it's building nuclear or building out this infrastructure to distribute power, it seems to be so heavy that it's affecting every aspect of this. So how is the regulatory burden reflected in these projections, and is it going to prevent the distribution of power more than it already is in the future?
Yeah, so certainly getting this interconnection queue under control is a big issue. And I think we are seeing progress on this. So I quoted that 5-year figure. Texas does a lot better on this. Texas is less than 2 years. Why? They just do less feasibility studies of integrating the power. So the model used to be you would build a coal-fired power station, connect it to the grid, and you do one big interconnection study about how this affects the flows of powers in the network. So engineers would spend all this time figuring out what was going to happen when you connected it. So, coal-fired power stations tend to be 1 gigawatt or 2 gigawatts, and they come in big lumpy sizes. So you don't have to do that many studies. Now that big interconnection queue with solar and batteries, lots and lots of small projects getting connected, 50 megawatts, 200 megawatts, meaning you have to do a study for each one of these and they interfere with each other. So you're doing a study over here, well, they have to take into account that you're connecting when I connect. So Texas has introduced just less of this. They said it's probably not going to be a problem, and so far it hasn't been from a safety and technical point of view. So I think there's big gains to be made just about streamlining the process, and it's certainly everyone is aware of this problem. The utilities are aware of this problem. The government's aware of this problem. I see this as mainly a transitional issue. This is probably not a long-term issue, but it's certainly a risk.
So I'm curious to hear your thoughts about the transition in terms of making cars that are hybrid or EV. How do you think that'll be affected in the next 20 years?
Yeah, so I've done a bit of work on this just from the consumer choice point of view. I think we have massively shot ourselves in the foot by essentially banning the imports of Chinese EVs. So if you guys have gone to any one of the auto shows recently, the Chinese EVs are very good cars. They have all these kinds of computer electronics, they're very efficient, and they're very, very cheap. Now, the Biden administration put essentially 100% tariff on Chinese EVs, would double the price of the car if you wanted to import it. And you think, okay, well, doubling the price of a cheap car, maybe that's not such a big deal. But the Chinese automakers took this as a sign that, well, we're just never going to be allowed to import cars. If we start importing at significant volumes, they'll just double the tariff again, and double it again, until we're shut out of the market. So, I mean, obviously the US was the technological leader in this space. Tesla is, uniquely innovative in electric vehicles. But it does look like they're being leapfrogged now by BYD, by others in China that are scaling up more quicker than Tesla can. And as a result, I mean, the transition around the world to EVs is just much more advanced in other places than it is here. China just crossed the 50% mark of EVs. We're at the 10 to 15% mark. It's increasing every year, but it's increasing about 1 to 2% every year. So the transition to EVs is probably going to be a lot slower here. Why? Again, arrow replacement effect. Tesla is our one EV company. We've got a bunch of legacy automakers, Ford, GM, and the like, that have big fossil fuel asset bases, big set of models that run on gasoline. And there's a big incentive for them to slow the roll to EVs just because they want to protect those profits. The hope was that, well, if we expose them to foreign competition, they'll have to hurry up. But we essentially shut out foreign competition. So, I've been optimistic about the EV transition for a while, and it's going quickly around the world, but it's much slower here because of policy.
Just talking on tariffs, there's been a lot of talk on the tariffs of raw materials from other countries.
Yeah.
How do you see that affecting the price of solar panels?
Yeah.
And then if so, how does that affect the timeline of solar panel development?
Yeah, so solar tariffs, they go back to the Obama administration. People have been trying to slap tariffs on Chinese solar panel manufacturers for a very, very long time. And so far, it hasn't been an issue. And why hasn't it been an issue? Because the Chinese solar manufacturers essentially just started setting up plants in Vietnam, in Indonesia, and surrounding Asian countries, and then just exporting tariff-free to the US. So the Biden administration, I don't know, seemed to try and have it both ways. They slapped higher and higher tariffs on Chinese solar panel manufacturers, but they didn't shut out the imports from these surrounding Asian countries. I think if the Trump administration really gets wind of this, that this is what's actually happening, we'll see tariffs on essentially everything. He's shown no restraint with putting tariffs on even our closest neighbors, Canada and Mexico. So that's a worry, right? If we start slapping general solar tariffs on, that'll slow this down for sure.
Can much be done on a state level for the interconnection queue and transmission problem? And then could you also just speak to enhanced geothermal, and is that how much potential you see there in the next 10 years?
Yeah, so I mean, a lot of across the US there, Utah is not part of one of these, but across the US there are essentially 9 big regional transmission organizations, or they're also called independent system operators. And they tend to be multi-state organizations. So you have to coordinate across a bunch of different micro utilities, but also different state regulatory environments. And yeah, that's why it's been so difficult at this point. It's just, you add complexity, you add regulatory bodies, and things become more difficult. But as I said, I think there is work being done there to streamline this process. On geothermal, we're seeing some very exciting things, I think, geothermal traditionally was only able to be done in very volcanically active or geologically active places, like around Yellowstone, let's say. now recent innovations coming off the fracking and the shale boom. I mean, you can set up geothermal plants essentially anywhere, and you shoot water down into the hot rocks below and get the power from the water coming back up. I will say this is a very nascent technology though. So, and current costs are, several orders of magnitude above solar panels. So I think we need to see significant, let's say, federal support for these technologies just to get them to start to scale. And 20 years from now, will we see geothermal be a big thing? Maybe. Next 5 years, yeah, probably not gonna happen.
The federal's regulatory actions on renewable energy, if they create more tariffs among other countries to source renewable energy here, could that have big effects on, or what are the effects on the environment for that?
Oh, sorry, say it again. I missed the first half of the question.
If the federal government regulates renewable energy more, so that it's like putting more tariffs on other countries to import solar panels, etc. How could that, or what are the impacts on the environment?
Yeah, so I mean, there's really two dimensions to renewables helping the environment. I think we all know one, right, which is less or zero carbon emissions. But the other big thing that gets missed a lot is the real immediate environmental consequences of fossil fuels are not carbon dioxide. Carbon dioxide is something that takes decades, centuries to start to have real health and environmental effects. What we really see is coal-fired power is one of the most dangerous things for public health, just in terms of the pollutants that come out, sulfur dioxide, mercury, all those things. And there's been a whole public health literature on what happens to air quality when you close down a coal-fired power station and the health benefits that come from that. Worldwide, we're losing almost 1 million people a year to air particulate emissions, coming essentially from fossil fuels. And depending on how you value those lives, this can be almost as big as the cost of climate change itself. So transitioning is not just a matter of good economics; it's a matter of public health.
So it could, other
So it could
forces
slow
are
that
in
down,
play that could
yeah.
make the federal government more open to renewable energy.
Absolutely.
Could you touch on some companies that you see being key players in this revolution to renewable energy?
Yeah, I mean, the obvious ones are the battery manufacturers. So not just Tesla, but CATL and the Chinese BYD as well. They've really been technological leaders in this. Battery chemistries are just changing super, super rapidly. And we're getting more and more energy-dense batteries. So what does that mean? Batteries get smaller and smaller. You can make cars lighter. You can install them in all kinds of places on the grid. That's where I see most of the innovation. The solar innovation is less about changing the panel composition and more about just changing the production process. Less waste, less material usage, bigger scale, this sorts of thing. In the US, again, this happens in AI, this happens in all kinds of technologies. The US usually starts as the technological leader. Most of the ideas are developed here, and then they ship overseas towards lower costs, right? Electric cars is a great example of that. And there was a lot of momentum in the Biden administration to try and get back some of that manufacturing into the US with great success. So the CHIPS Act and the Inflation Reduction Act seem to have led to a lot of manufacturing of batteries, of solar panels, of chips coming back. The real question now is, is the Trump administration going to keep continuing these policies and developing American champions? And I hope so, but it's certainly not a done deal.
So do you think the increase, with the Trump administration, we could see an increase in energy M&A? Do you think that could potentially help speed up the process?
Yeah.
To bring it in?
No, I think that's right. I think being open to that is certainly a strength of the Trump administration, so hopefully that could speed things up.
Thank you.
Just wondering what you think of hydrokinetic energy, especially in places where they don't have a lot of land to use for solar panels or wind turbines.
Yeah. So, I mean, hydro has been a very, very successful technology historically. It's very cheap supply of power, just on a marginal cost basis. It can also be used for storage as well. You can pump water back uphill in dams in times of negative or low power prices, and then let it flow down and generate energy again. The thing about hydro is, in the US, and indeed in a lot of the world, we've almost fully tapped out the hydro resource. Rivers, dams, there's just not a lot extra that we can do on hydro. I mean, you look at China. China just announced a new dam they're thinking about building on the Brahmaputra River, just off the Tibetan Plateau. And it's going to be 3 times bigger than the Three Gorges Dam, which is amazing. So that'll avoid some extra coal-fired power stations coming online in China. But the capacity of that dam, the biggest dam ever built by a long way, would be 60 gigawatts. So that's big. But China installed 300 gigawatts of solar last year. So there's just, I mean, it's limited by geography what you can do. In some sense, it's not a scalable technology in the way that renewables are. Solar.
Like with the recent proposals to maybe reverse drilling bans and subsequent deregulation of the oil and gas industry, do you anticipate that maybe substantially revitalizing the oil and gas industry, and how would that affect the transition to renewables?
Yeah, so the US, for the first time in its history, is now a net energy exporter, as in we export way more if you add up gas and oil than we import. And that's good for the US, as in it brings in a lot of export revenue. But freeing up drilling is not about lowering power prices in the US. It's about strengthening export industries. And just kind of historically, like if you look back at that chart, this era of expensive fossil fuels, even with the shale gas revolution, natural gas and oil is just much, much more expensive than it used to be. And so deregulating drilling will help us with export revenue, but it's probably not going to help us with power prices.
Yeah, I wanted to ask you a question. As of right now, we use fuel tax to service some goods, public goods.
Yeah.
How would you say that we should go about taxing renewable energy to provide for these goods?
Yeah, it's a great question. I mean, I think one good example is, this happens in various places in the US, but also all over the world. We tax gasoline to try and get revenue to build our highways and public roads. And once you transition to EVs that don't use gasoline, where do you get the funds for doing this? Well, one argument is you should just get it from general revenue, just increase taxes on everyone else, and then we can fund roads and bridges that way. But it doesn't speak to this common principle in economics that the user should pay. So I think a lot of what we're seeing in different jurisdictions around the world is registration fees for EVs can be more expensive than gas cars because they bring in less gasoline tax revenue. But how do you offset that? Well, when you go to register the car, you pay $500 or something to register an EV. That may slow the rollout of EVs, but I see that as essentially an equitable and fair way to fund public highways, given the models that we're using already.
I wanted to add, wouldn't you say that that in the long run won't be enough to cover?
Yeah, it's I haven't looked at that in detail, so it would be about getting the price right. So you can do the upfront registration, but you're right, you do need to pay for the wear and tear that you're causing on public roads when you drive, in big cars, EV trucks and the like. But economists are very good at doing those sort of calculations, so I'm confident we can get the price right in the long run, even if we're not getting it right now.
Are there any risks in decentralized markets, and how hard is a transition to a decentralized?
Yeah, no, so I'm generally in favor of decentralized markets. I think California's transition was pretty rough. You've probably all heard of Enron and the things that went on there. The principles behind decentralized markets, I think, are sound. Allowing competition, allowing the lowest cost sources of supply to bid in to supply the grid, instead of having relatively inefficient, publicly regulated, vertically integrated monopolies. Empirically, I think it's been a success in most places it's been tried, but it does depend on the structure of the market that you set up. So Australia has been relatively good at this, South Korea has been pretty good. It's certainly not a panacea, because you're moving away from something that's regulated for the public good, as in not a profit maximizing thing, to opening up to competition, but from capitalists. And so there's some sort of trade-off there in trying to keep prices low for public good versus the efficiency of capitalism at delivering the lowest cost sources of supply. In the long run, I think decentralization is the way to go, but I'm certainly not an ideologue about that.
Given the future, you're saying cost projections of is going down and how much you think more and more power companies will start to use them, how does that get affected by the future potential deficit of lithium mining, given that?
Yeah. So we thought this was going to be a problem. We just didn't have huge lithium ion deposits at scale in the world in the last couple of years. But that was mainly because we weren't looking for it. You know, we needed lithium ion batteries to power our iPhones and MacBooks, but there's just not a huge source of raw material demand. But as soon as we started looking for lithium ion, we discovered it kind of everywhere. Australia has huge deposits, Argentina has huge deposits in really like safe, well-regulated, well, Argentina is an exception to that, but yeah, Canada, Australia, the US, these things are pretty safe. And this is not something that's going to be dominated by one country. This is not like oil where you can have a cartel. You're going to have just lithium itself is one of the most abundant elements in the Earth's crust. So I don't see this as a huge issue, constraining EVs or constraining vehicles.
A lot of like batteries and solar panels are heavily reliant on critical minerals, and many of the extractive industries for critical minerals. We've passed on that process to other countries, and in most instances, developing countries. And in the scenario you've explained, like the U.S. reaps a lot of the benefits of cheaper renewable energy. Do you have discussions or thoughts around offsetting the costs, social and economic costs faced by those countries and communities that are responsible for those extractive industries?
Yeah, so this, there is some sort of public concern about this, that particularly with cobalt, which goes into older generations of lithium-ion batteries, there's a lot of human rights concerns about the places these are mined. So one big one is Democratic Republic of the Congo. Though, I will say, very quickly, companies are responding to this sort of social pressure. So Tesla has got cobalt out of its supply chain almost entirely at this point. And as I said, lithium is not a concern. We do lithium mining in the US at scale. There is also a question of recycling this stuff. So is there going to be long-term environmental costs of recycling lithium? I think the answer to that is yes, but we have to keep in mind the scale of this stuff. So when you dig out a ton of coal from the ground or dig out a ton of lithium, they have roughly equivalent cleanup costs. But you burn the coal today and it's gone. You turn the lithium into battery, it's around for 30 years. So you need to amortize those social costs and economic costs over a completely different life cycle for fossil fuels and renewables. It's not something we should ignore, but I think it's a relatively minor issue.
Another question.
I was wondering if you see hydrogen as potentially replacing some of the coal and gas to counter intermittency and other fuels.
Some countries are taking big bets on hydrogen. Why? Again, it's this idea of what do you do with all the cheap power. So you're going to see periods of almost free electricity, and you can use that to build up storable hydrogen. And the other thing you can do is make steel with it in a relatively clean way. So steel has big carbon emissions for two reasons. One, it's electricity intensive, but also you need coal to make steel. But companies around the world are developing alternatives to do this with hydrogen, to do this with other materials. So, I'm optimistic about hydrogen. Again, it's one of these pretty nascent technologies, though. It's kind of 20 years in the future, we might see a lot. I was like, Toyota really missed the boat on this. They were betting on hydrogen fuel cell technology, and Tesla kind of ate their lunch by developing cheap EVs. So they're now well behind in the EV race worldwide.
Conor, there's a narrative in this state that we shouldn't be permitting data centers, that they're going to suck up power that our residents need. What are your thoughts on that?
Yeah, I mean, again, this is one of these things that is just changing so quickly that it's on the day-to-day scale. So I was saying yesterday, I've seen pretty breathless projections about what AI data center demand is going to do to energy demand in the US, ranging from 10% increases to 50% increases in the next 10 years, on a background of electricity consumption in the US being flat for 20 years. So that would be a big change. but I think we just don't know. Data centers now are like 1% of power usage nationwide. And the question is, I'm not an AI expert, so probably it's better to ask AI experts about this. But the question is, how efficient are you at training these algorithms in using power? And I think we just don't know this yet. So everyone will have seen DeepSeek come out over the last week or two, essentially reducing by 95% the power costs of training some of these frontier models. So when that kind of technological development is going on, I think it's just too early to say what's going to happen to power demand. This kind of thing needs to shake out over the next 2 or 3 years, and then we can start to say, is this a problem or not? Right now, the levels are just too low to matter, to show up in any significant way.
What are your thoughts on the integration of renewable energy in third world countries?
Yeah, so the issues are very different in third world countries. So particularly different parts of sub-Saharan Africa are facing large swaths of the population without access to electricity at all. And why is that? Well, limited state capacity in building out transmission lines and building power stations and the like. Distributed solar has actually come a long way in serving some of these underserved populations. So in different parts of Africa, you can use very, very cheap solar cells to run lighting, to run cooling and the like. That's been a really optimistic trend. It's been a way of getting around the limitations of state capacity to build out these centralized generation assets. But I want to emphasize, there are essentially no countries in the world that are rich but don't use a lot of electricity. So the way to get rich is essentially scale up power usage and use it to power technology. And there's no way sub-Saharan Africa is going to develop to Western levels of living standards without substantial amounts of power. And I don't think distributed solar gets you there. I think you need to really build out a traditional grid for that.
I mean, I was going to say, is this already having an impact in those countries?
Certainly it's showing on poverty statistics. So access to electricity is going from 0 in some areas to a lot of households having 1 or 2 solar panels on their roof that's supplying their needs. Is it showing up in growth statistics? No, not yet. It's too small to matter.
It's surprising because I think about cell phone technology where they basically skipped over the landlines and they went right to cell towers, and you don't think the same thing's going to happen?
Maybe not so much with distributed solar, but what we are definitely seeing, take India for example. India is scaling up all its energy sources, renewables in a big way, but also coal-fired power and gas. We're never going to get to a point though where India looks like the West 40 years ago, where the grids are almost entirely fossil and nuclear supplied. India is going to peak at probably 40-50% fossil fuels and then start to come down that cost curve and renewables will dominate. That kind of leapfrogging I see for sure, and China would be another example of that.
Do you see any countries not switching to renewable energy?
Yeah, so Europe, funnily enough, is the most environmentally conscious group of societies in the world, but also one of the worst places to do renewables. The wind resource is not super good, and one stat I like is that if you put a solar panel in Arizona, it'll generate 3 to 4 times the electricity you'd get in northern Germany. So the resource is just nowhere near as good. And at the same time, they're really trying. They're pushing as hard as they can, but it is running into these kind of teething problems that the resource is just not as good, meaning the costs are much higher than they are for the US. So, Europe will get there, and they'll probably get there before us just through policy support. But, running nuclear there was probably a much better idea than trying to quickly go to renewables like they've been doing.
Do you see AI playing any role in the efficiency of batteries and solar panels and kind of increasing this curve you're talking about?
I mean, I'm the wrong person to ask for this, but the things we've been seeing coming out on a daily scale, discoveries of using AI for innovation in just the last year or two, make me very optimistic. So could we use AI to come up with new battery chemistries or new configurations for solar panels? I certainly think it's a possibility. All it's going to do is accelerate this transition.
One more. Okay.
I would just say that for the US to incentivize renewable energy? Because I feel like, I don't wanna say what party, but there's a party specifically that doesn't wanna push for renewable energy. How would you say for the US to push for renewable energy?
I mean, if you're making the case for it, I think you make the case on cost. So this is not, again, not about environmental benefits. It's not ideological like this. This is just cheap. But I will say we already do support renewables in a lot of ways. So the Inflation Reduction Act was big. People are getting those tax credits right now. The question is, are they going to be taken away? Unsure. But yeah, I think you can, you can always make the case for renewables on cost now in a way that was not possible 10, 20 years ago.
Okay, well, this is awesome. Thank you.
Thanks a lot. Thanks.